Hi, this is Mrs. Sykes, and today we're having a look at surface area to volume ratio, which sounds kind of scary. Basically, it's a mathematical way of measuring how spread out something is. So you quite often see this written as surface area volume ratio, like that, but that doesn't really help. This entire phrase really means how spread out something is. It is a measure of spread outedness, which, yes, I'm pretty sure is not a word, but it does tell you what it does. So if something is very, very spread out, then it has a high surface area to volume ratio. It has a lot of spread outedness. If it is quite close together, like this ball, that's not spread out, therefore it has small amount of spread outedness, it has a small surface area to volume ratio. But if I change the way that this is arranged and I squish it, now it is more spread out, it now has a higher spread outedness and a higher surface area to volume ratio. And what we find in nature is that animals in general go between three basic body plans. A ball, which is the smallest amount of spread outedness that you can have, a flat section, or sometimes what we have is that ball will be changed into more of a sausage shape. And if it's changed into a sausage shape, that can provide maximum amount of spread outedness and a maximum amount of surface area to volume ratio. And depending on what type of animal you've got will depend on which one of these it will choose. Now, I very obviously have raided my daughter's sticker collection for this bit. So with one type, you have got, based on this sausage shape, we've got worms, we've got snakes, and lots of things like that. But we also have animals that are also based on this shape, but a little bit more convoluted, a little bit more folded up, or a little bit fancier. Things like our seahorse is obviously long and thin, and if we unwound the tail, would be that basic shape. So this is also the same kind of idea. And on something like an octopus, you have got long, thin tentacles, and then you've got a long flat bit, which is folded up to make the top part. So that has a massive surface area to volume ratio. Surface area to volume ratio is helpful for two basic reasons. The first one is heat loss. So if you want to have an animal to stay cool in a hot environment, like an elephant, for example, you would add on something to it which has a large surface area to volume ratio. So in this case, in this African savanna elephant, we've got these whacking great big ears which provide it with a bigger surface area to volume ratio, more spread outedness than it would normally have. And that allows the heat to come off these ears and cool the animal down. We can use this idea to tell us about animals that we've never even seen properly in existence. So this particular dinosaur here, with its large fin on the back, we can guess, if we look into paleontology, so we look into the study of prehistoric dinosaur creatures, this is probably to help it maintain the correct temperature, because in exactly the same way as the elephant loses heat, this heat would go through these fins and go into the atmosphere, into the air, and would cool this animal down. So it's a cheating way of cooling you down when you can't sweat. Most animals that live in hot climates tend to be tall, skinny, lanky, like a giraffe. But if you have something like an elephant, you can have it be quite fat because you've got these extra bits to help it. Having a large surface area to volume ratio can give you other features. So it can make it easy for you to fly, for example. It can make you particularly flat, which can make you really good for hiding in different situations. For a jellyfish, it's even more useful because a jellyfish doesn't have a heart and a lungs and a transport system like we do. It just lets everything diffuse in and out of the water and in and out of the animal. It doesn't need one because it is so thin, It's got such a big surface area to volume ratio, it's so spread out, it doesn't even need one. So as a general rule, if we're talking about an animal having a large amount of spread outedness, it tends to be because of heat exchange, trying to keep the body cool. If you are talking about something that is on an organ level, so if we were talking about the lungs, for example, especially if we were talking about something like the alveoli inside the lungs, the alveoli look a little bit like a bunch of grapes. These are more spread out than they would be if it was just a ball. So because it is more spread out with a larger surface area to volume ratio, you can have more gas exchange, more things travelling across into where our blood would be. If it had been simply a circle instead, there would be less places that it could do that. So if it was just a circle, you probably wouldn't be able to do that one, probably wouldn't be able to do that one, and less things would be able to travel across. So surface area to volume ratio sounds really complicated, but actually it's all about how spread out things are. And it's about helping with heat and keeping animals' bodies the correct temperature. And it's all about something called diffusion. And diffusion is all about allowing things to move one way and then the other, usually to maximise respiration. So surface area to volume ratio is how spread out something is.